Alright guys, so welcome back to another video. Now we will be doing an assignment on logistic regression. We have already covered a detailed exercise on linear regression. You might want to check it if you haven't done it already. Now in this assignment, we will again use the German credit dataset. So without further ado, let's read the data and store it in a variable called German_credit. So as usual, we will use read.csv function to read our file as shown here. Now if you see here, I have removed the columns that were numeric. You could load the complete data and check it, but I have already worked on it, so I know which all columns are numeric, hence I have removed them. Then you can check the structure of the data if you want to, but since we have already done all this, so I am skipping it. After that, we will check if there are any missing values. So we can use sapply function as we did earlier. So the first argument would be the dataset, that is German_credit. And the second argument would be the customize function, which will check if the value is NA or not. We will store it in a variable NA, and then we can check by using sum function. And as you can see, we have 0 NA values. Now checking the outliers, checking the NA values, normality, etc. We check the structure of the data, we understand the data by checking the summary of the data, and so on. All these things are a part of data preparation. So in general, all these things are done before getting into the model building. But I will not be doing it in all the assignments because we have already seen it. But just to give you an idea, I sometimes show it. Now we will move to the first question, question 1. Question 1 says, use German credit dataset to build a logistic regression. So first we will perform a train test validation. We will split the data into training part and test part and then build the model. So the first step is to set the seed. I have already explained the purpose of seed in the previous assignment. So we will first set the seed. After that we will create a training observation variable by the name trg. We will use sample function to create this. So we can generate a sample using a vector as true, true, true and false. And then generate 1000 values. Now here we are giving 3 true and 1 false, which means it will be around 75% true and 25% false. In short, we will have 75% value in training data and 25% value in the test data. You could use any other method like we did earlier, or you could choose any other number as well. But I am just trying different ways and also bringing in more and more randomness in the samples. After that, we will create a variable test, which will have all the observations other than the training observations. Once training and test observations are created, then we'll move on to creating the model. Now for logistic regression, we will use GLM function. But as far as the rest of the arguments are concerned, they will remain the same as they were in linear regression. So here we are regressing class onto the rest of the variables in the training data. We will also have to mention the family as binomial for logistic regression. We will read about this in the explanation given below. But before that, we will run this and create our model. Now we have stored the model in a variable called reg_trg, which basically is a short form for regression and training. So as I said earlier, these are just my notations so that I can remember all these. You can use any other name of your choice. Okay, so now as you can see, the explanation is given here. So let's read the explanation here. Now the family argument is used to define the link function. Unlike linear regression, which assumes that the response variable follows a normal distribution, GLM, that stands for generalized linear model, can take response with distributions other than normal. A link function transforms the probabilities of the levels of a categorical response variable to a continuous scale, that is unbounded -infinity to +infinity. Now once the transformation is complete, the relationship between the predictors and the response can be modeled with linear regression. For example, a binary response variable in case of logistic regression can have two unique values. Conversion of these values to probabilities make the response variable range from 0 to 1. But when you apply an appropriate link function to the probabilities, the numbers that results will range from minus infinity to plus infinity. So that is the whole idea of applying the link function. So basically it converts the probabilities from 0 to 1 to minus infinity to plus infinity, and then the response is modeled using the linear regression. Even if you are not able to understand this, just skip the theory and remember that whenever you want to do logistic regression, you have to mention family is equal to binomial. That's it. Now we will move to the next part, which says test the model using the test data. Now in the previous step, we created a model using the training data. Now in this step, we will predict the data using the test data. For this purpose, we will use predict.glm function. Now the first argument is the model that we have built, which is stored in reg_trg. Then we will have to give the data using new data function. This new data will be the test data. So we will subset the data frame German_credit using the test variable that we had created earlier. This will give us the test observations. And in the third argument, we will mention type is equal to response. Now what is type? I'll explain it in a moment. But before that, let's run this code and store the results in the variable reg_test. Now as you can see the explanation, there are three values that type can take. The first one is type is equal to response will give values in natural scale. That is, it will return the predicted probability. The second is type is equal to link. It will give the values of logit function of regression. So if we mention type is equal to link, it will give the value of that function. And the third one is type is equal to terms. It will return a matrix of fit for all values. So in our case, we only needed the predicted probability. So we have mentioned type is equal to response. So that is how you create a logistic regression model and make the prediction. Now the next part is to validate the model by calculating the error rate of the test data. So if our model is performing good on the test data, then only it can be considered a good model. So to know this, we will have to validate our model. Now for validating the model, we will have to create a confusion matrix. Again in module 1 we had studied confusion matrix. So basically we use it to assess the model performance. Now if you want to know more about it, you can either check the video from module 1 or you can read more about it on internet. It's a pretty straightforward concept. Okay, so let's see how do we create the confusion matrix here. So first we will load the library caret, which is an inbuilt library. So we will use library function and mention the word caret. You will get all these warnings. You can just skip it. There's nothing to worry about it. After that, we will create the confusion matrix. For creating the confusion matrix, we will use the table function. And then the first argument would be the class variable from the test data. Now our class variable has two labels, good or bad. So we can first subset the German credit data using the test variable for using test observations only. Now the first argument would be only those observations from the model that have probabilities greater than 0.5. Now the first argument would be only those observations that have probabilities greater than 0.5 in the variable that has the predicted values. So reg_test is the variable that has all the predicted values or all the predicted probabilities. Now if you see after reg_test, I have mentioned as 1:10. So for demonstration purposes, I am only using 10 values. But in reality, we will be creating the confusion matrix for the entire data set or for the entire test data set. So reg_test square bracket 1:10 will return 10 predicted values. And then greater than 0.5 means if the probability is greater than 0.5, it will return true. Otherwise, it will return false. Then the second argument would be the class variable from our test data. Now our class variable has only two classes, good or bad. So we can first subset the German credit dataset using the test variable for using the test observations only. So we have mentioned German underscore credit square brackets test. Then we are using $sign to subset the class variable from it. Because first part of the argument will return all the variables. And here we only want our response variable, which is our class variable. And after class, we have mentioned 1:10, which means we need only 10 observations. After that, we will close the brackets. We will run this function and store it in a variable called CF. Then we can print the CF variable. And we can see here the results are printed. Now what table function does is it matches the values of first and second argument and build a confusion matrix. Now as you can see in the table, here false is referring to the bad category and true is referring to the good category. Now we know that in a confusion matrix, the diagonal elements are the correct classification. So if we sum it and divide it by the total number, we will get the accuracy rate. Or in other words, we can use the sum of the off diagonal elements and divide it by the total to get the misclassification error rate. We can add the diagonal elements and divide it by the total and we will get our accuracy rate as shown here. Now again I have included the explanation. You can read through it if you have any doubts. Now we will move to the next question, question 2. It says use the summary function to view the diagnostics and write a summary of the results. So we can use the summary function and give our model as the argument and we will store it in a variable sum. Then we can print this variable sum and we'll get our summary printed. Now again I have included an explanation of the summary. So let's check the explanation given here. Now the point 1 says from the above summary we can see that there are 12 singularities R has detected. This is due to the correlation between variables and R has detected it and hence returned NA for these variables. The second point says from the above summary it is evident that except few variables which are listed below, most are insignificant. The third point says significant variables can be seen using the significance code, which is basically the asterisk against each variable. So if you refer to the summary, there are few asterisks marked against few of the variables. This means these are the significant variables. Now their level of significance can be understood from the significance codes given here. However, one important thing to note here is that within the variables property and other installments, some levels are significant and some are not. So if we go back to the summary, we will find that levels such as other installment plans.bank is significant, while other two levels, other installment plans.stores and other installment plans.none, are not significant. And hence the entire variable should be dropped for further analysis. So point 4 says, among the significant variables, both of them have negative coefficients and hence for every 1 unit increase in x, log of odds will be decreased by beta of these variables. So if you go back to the summary, you will find that significant variables have negative coefficients. After that, point 5 says the null deviance shows how well the response is predicted by the model with nothing but an intercept. And the residual deviance shows how well the response is predicted by the model when the predictors are included. Now if you see the difference between residual deviance and null deviance, you will find that there is a decrease in the residual deviance, which means that there is a little decrease in deviance upon adding the variables. Now a good model is the one that has small residual deviance values. Now the last point says the Alkaline information criterion, which is AIC, provides a method for assessing the quality of your model through comparison of related models. It is based on the deviance but penalizes you for making the model more complicated. Much like the adjusted R-square, its intent is to prevent you from including irrelevant predictors. So it is very useful for comparing models. So if you see after the residual deviance, we have AIC values. Now if we have multiple models, we can take AIC values of each of these models and then we can compare these models. But individual values of AIC are of little use. So that is what we get to know from the summary function of our model. Now there are few more information given in the summary function, but right now that is not required, so I am not including them in the explanation. Now we will move to the next question, which is question 3. Now the question 3 says, do you like the model or not? Whatever is your stand, you need to give the justification for it. Now as you can see in the response, it says the model is not a very good model because of the following reasons. Firstly, there is a small decrease in the deviance null to residual, and also the residual deviance is high. That means it does not define the data pretty well. Secondly, most of the variables that we have seen in the summary are insignificant. So these are the two primary reasons which makes me feel that this model is not a very good model. So if you move to the next question, question 4, it says, how would you determine what is the best model? The response to this question is that a more parsimonious model that has a lower residual deviance would be the criteria to choose the model. Now the parsimonious model is the model which has the optimal number of variables. We can also use a confusion matrix to assess the model performance. Also, selecting the best model is not a very straightforward and simple thing. It comes with a lot of experience. It requires a lot of back-end work as well. And there are multiple factors based on which we select the model. So this was just to give you an idea about the selection process and also to make you think in that direction. However, this is not the final say. Now moving to question 5, it says, how will you determine which interactions to add to the model that you built in part A? So the response for this is that we can test for multi-collinearity by using VIF among dependent variables and decide the potential variables for interaction. Or many a time it can come from the business as well, and their suggestion can play a vital role in choosing interactions. Now guys, remember all these theoretical questions are there to make you think in different directions. Questions like selecting the best model, dropping a variable, or adding interactions, all these are complicated things. And these things come from experience by doing a lot of careful examinations, etc. So there is no black and white answer that you do this and you will get the best model. And since it is a complicated task, that is the reason it is valued in the industry. But all these things will help us understand the concepts and will help us think in the right direction. These things will be the building blocks for a good data science career. Sometimes it might sound basic, but remember basics are always important and will always be useful for you in the longer run. So my suggestion is never skip the basics and try to focus on these concepts. Now that will be all from this assignment for now. In this assignment, we have covered logistic regression, we have created confusion matrix, then we went a bit deeper into the summary of the model and learned few concepts regarding the model selection. Okay, so I'll take your leave now. We will expand our understanding of logistic regression in the next assignment. So I'll catch you up there. See you.